Good morning, good afternoon, good evening, whenever you're watching this, everybody. We're going to take a look at a section that deals with, again, hypothesis testing, but it works with looking at two different situations, two different samples. We sometimes will call it dependent. And then there's others that are called independent. Matched pairs, sometimes this section is going to be called. And for instance, your exam that you're going to be taking, there you could have a pre-test and then a post-test. So for instance, I could giving you a pre-test and then a month later give you a post-test and see if there's a difference in your scores, and meaning that you would think that after a month your grade, your score would have increased because you've had a month to learn and practice and get ready, given that it's the same test. And so sometimes we call those matched pairs, and we're going to take a look at how to handle those, especially with hypothesis testing. A lot of the process that we're going to be doing is all the same that you've already learned. The difference is taking a look at two different samples, and they're called matched pairs. Usually it's like a before and after. Here's the before results, and here's the after results, and what's the difference look like. Let's see, what else? Pre, post. The pre is first and post. And then we're always going to do the after minus before. That's in our class, after minus before, or post minus pre. Sample 2, sometimes our book will have sample 1 and sample 2. We're going to do sample 2 minus sample 1. All right, let's take a look and see how this works. So as I said before, we're going to be comparing, in this case, means. There's a section that compares proportions, just like there's confidence intervals for means, and there's one for proportions. This has the means dependent, and there's a section on comparing the means for independent, and then there's a section on comparing the proportions. So in this chapter, we're comparing averages between two samples. Sometimes you have prior knowledge of the population standard deviations, and sometimes you don't. When you don't know the population standard deviations, we make some assumptions regarding those population standard deviations, and we would use a t-test if we're able to do that. And again, it's all based on being approximately normal. All this said, finding confidence intervals and testing hypothesis between the averages sometimes have become very challenging, and we're looking at different formulas. Because of the time, we're going to look at through the following situations. We're going to look at dependent in this video right now, and we call them matched pairs, as I said. And the second, that'll be another video if we have a chance. The second would be independent means. The difference between independent and dependent, again, this first one's going to be what's called a dependent means. Two samples drawn from two populations are independent if the selection of one sample doesn't affect the selection of the other sample. So let's see. For instance, if I'm going to take a sample of guys and a sample of girls, having the sample from the guys has no effect on the sample from the girls. That would be considered independent. If the sample of, let's say, the exam that I talked about, and the one sample was the exact same people, so it's the exact same people, and it's test 1, test 2, but the exact same people. That's considered dependent. So we're back to, again, the only way that we can consider moving forward is case 1 and case 2, normal or the sample size is large enough. Some new symbols, mu sub d, that's the mean of the differences. Little d is for the differences. And x bar is the sample average of the differences. Let's see, what other? So the hypothesis testing, as you can see, there's 3 different scenarios that we've done in the past. Left tail, right tail, and then two tail. And it's all based on the alternate hypothesis. So greater than is going to be a one tail right, and a less than is going to be a one tail left, and a not equal to is going to be a two tail when you draw the pictures, the bell-shaped curve. The way I'm going to do it is, if you've got a greater than, this would be the complement symbol, less than or equal to. The textbook, again, sometimes would just make this equal, make them all equal, actually, because that's really all you're doing. Is it's good enough to be equal because you're either going to reject or not reject the null. Ideally, you're always wanting the claim or what you're testing on this side. So if you reject the null here, you accept what's going over here, which is what you're trying to talk about. If you don't reject the null over here, you still talk about what's happening over here in those sentences that we had done before. The explanation, the interpretation. The T data, okay, this is a formula for it. Don't worry about it. We're going to find it using your calculator. Find it using the calculator. So we're not going to worry about the handwritten formula. And the p-value is going to be found by using the calculator as well. Okay, let's keep going. So example 1 that I've got up here, we're going to set up 3 different hypothesis tests for the difference between these 2 samples. We're always going to do sample 2 minus sample 1. So let's do the differences. I'll write differences. So when I take 2.5 and subtract 3, I'm going to get negative 0.5. Again, in your calculator, you're just taking 2.5 and subtract 3. And then 2.5 subtract itself would be 0. 2 subtract 3.5. 2 subtract 3. And here we get negative 2.5. Now, we've got numbers, 1, 2, 3, 4, 5 numbers. These are called differences. So we've got these 5 numbers, and we don't have a sigma, not given. So we're going to have to use a t, and we use a t as long as we have a sample size that's bigger than 30, which we don't. So then the next thing that we would end up having to do is put these 5 numbers into our list 1 and take a look at the dot plot to see if it looks fairly straight. But all this one is asking, I'm asking you for, is just set up 3 hypothesis tests. So here's your first one. This would be mu sub d. Let's do this one, the equal, and then h sub a. This one's not equal to. Now, what you're going to set it equal and not equal to is always 0. Because the idea is it negative or positive or equal to 0? I'll say that again. If I look at all these numbers right here and took the average, wouldn't the average still be negative? I'm just looking at signs. 4 out of the 5 are negative numbers, so the result should be negative. So you're comparing it, when I say this, you're always comparing it against 0, either equal to 0, greater than 0, less than 0. That's what these symbols were saying. See all the zeros right here. Always that way. And this one over here. So this would be called a two-tail. Two-tail. Let's do this one greater than 0. This one here is going to be less than or equal to 0. Now this one here is a one-tail, and greater than means it's shaded right. So it's a one-tail right. Now the last one, that's not. Let's make that the null hypothesis. Since this was the greater than, let's make this the less than. And that means greater than or equal to on this one. And this one is a one tail left. Okay, so we're always looking for differences. Take the post minus the pre, the sample 2 minus sample 1, come up with the differences. In this case, we have raw data, so you'd put this in the list 1 eventually, which this one's going to give us an illustration of that because the samples, it's not 30. So we're going to have to look at the picture anyway. And then once you put it in your calculator, you're going to look for specific values. I'll show you where that is and what test that you're going to use so that you can get the data value, the critical number if you needed that from the table D, and then the p-value, and make your decision like we've done before. All right, let's look at example 2 as being one of the detailed ones that would demonstrate this really well. So suppose we want to determine if a diet drug is effective. And to determine the effectiveness, we're going to select 10 volunteers. So N is 10, not big enough yet to be normal. So we're going to take a look at the dot plot in a moment and measure their weight before the diet drug treatment, measure their weight before, and then we're going to measure it afterwards. And wouldn't you think if the drug works that the weight goes down? So actually you're losing weight. And so we're going to take a look at what those results might look like. So this is before the drug, and this is the after. And person, letter A, person A, they weighed 190, and now it's 184, so they lost weight. So right now, that looks effective for that person. Yes, yes, not much, but yes. No, this actually gained weight. Yes, yes, no. So far, a lot of yeses over no. Yes, yes, and yes. It looks like there's only 2 people that it wasn't effective for. So you might say, hey, 8 out of 10 should be fine. But that sample, that could have been an anomaly. Meaning if you took another sample of the 10, the results won't be the same. Maybe it wasn't effective for the average of those. But we're going to use statistical evidence on this and to see if the company's claim that it is effective is actually true or not. And the significant level, that's an alpha. Alpha is equal to 0.05. That's what we're going to measure it against. Okay, flip the page. First you want to do is calculate the differences. So 184 subtract 190, that's -6. This is -7, -1, +5, 208 subtract 203. Remember, you're always taking the after minus before right here. All right, 246 subtract 262. So you go 246. Yeah, so -16, -16, -3, positive 5, 225, subtract, that's 238, negative 13, negative 8, and it looks like this would be negative 12. So we need to determine if the differences are normally distributed. So let's do a dot plot. So now what I'm going to do is go into stats, and you know that we're going to end up doing list 1. So edit, get rid of all the other stuff that we had before, like we've done, and start entering the differences exactly this way with the negative. Now the negative sign you're going to use is this one on the calculator. This one is a subtraction. That's the one you want to use right there. So for negative 6, I'm going to go negative, it's a little negative sign, and 6, and keep typing in the values. So again, what I'm going to do is I'm going to hit this negative sign and then 7. See, so there it is, and then hit enter. Negative 1, positive 5, negative 16, negative 3, and 5. And then we've got negative 13, and wrapping up with negative 12. And then the next thing is, since I've done this before, all I have to do is do zoom standard. Zoom with the 84 calculator, we go zoom standard is number 9. Standard is way down there, not that one. Zoom stat. And looks pretty close to me. I mean, you might have a little, you say, well, that's a little off there, but generally speaking, that's pretty straight. So we're going to say looks approximately normal. And we want to test the hypothesis that the drug has been effective. That's because there was a weight loss. That's because the numbers look negative. The average looks like it's negative. If you add up all these right here, divide by 10, you're going to get a negative number. That's less than 0. Less than 0 means negative. And this is the complement symbol. And alpha level is equal to 0.05 from the previous page. And now we're going to find a p-value and a David value and a critical value. So here we go. Let's do the p-value and the data value first. Comes from the calculator. Go to tests. And what we want is a, we're going to do a t-test right here. You might think, hey, what about a 2-sample t or z? Now, you're only going to use that if it's independent. 3 and 4 is not for this section. You're going to use plain old 2. And the reason for that is you just got one list set of numbers right here. So everything's the same for a t that you did before in a previous chapter. So we're using the t-test for all these problems, a t-test. And you're going to use data because that's where we draw upon the data. Mu sub naught, that's always going to be 0 for pairs. Drawing from list 1. Which of these do I want? Oh, there it is right here. So go to the right, highlight that, calculate. This is a data value right here. So we've got a p-value Okay, the p-value is about 0.0179, and the crit value So then if you've got a crick value and you're using a T, you need degrees of freedom, which is n minus 1. So that's 10 subtract 1, so that's 9. So you get your table out, and it's a one tail, and 0.05 is here, and I'm looking for 9. So 1.833, 1.833. Is it a negative or a positive because of the tail? It's a one tail left, so shading left, this would be a negative. So if I did that bell-shaped curve and just, here's 0, and approximated the crick values over here, negative 1.833, and all the shading is over here. You see how the T value is in the rejection region? I mean, the data value is in the rejection region. And as well as you compare the p-value and against the alpha, and the p-value is 0.0179, the alpha is 0.05. See how that's smaller? And that's also reject. So what we do is reject the null. So that means we go back up to here, we throw that away, we reject it, get rid of it, gone. This appears to be true in that if this is gone, this is the only thing that I have to look at, which looks like it's effective. Looks like the drug is effective. So it looks like there's enough evidence to say that the weight loss drug looks to be effective in helping people lose weight. That's really all there is to it. When I say that, everything else looks the same. You just have to decide about the symbol, whether it's less than, greater than, or not equal to. So that would be your tails on your bell-shaped curve. But to make a decision, all you need is a p-value. And you put all the raw data in, which are the differences, into your list 1 and find the p-value using always number 2. Tests, t-test number 2. That's what we always do. So with that said, that's one good example. That's all you need to do. Take a look at the textbook examples. They've got 1 or 2 other ones. And if you've got any questions, you know where to find me. Send me an email. I'll be happy to help you out. And that's for Chapter 10, Section 1. Okay. Be safe, and see you next time.